Welcome to BKSS Academy. I hope you are in fine state. Now we will discuss about depth first search algorithm in data structure. It is defined as it starts with initial node of graph G and goes deeper until we find the goal node. Goal node means which has no child node. So it's an example I have given here. That is, this is the graph. First I will find out what is the neighbor nodes to every node. So suppose I am wanting to start from A. So what is the neighborhood of A? That is B and D. I have written here. Similarly, neighbor node of B, that is C and F. I have written here. Similarly, what is the neighbor node of C? That is G, H and E. If that is directed towards E. If it is directed reversely, that will not be considered. So we will consider two things, that is a stack where we will keep the values. First, in step 1, push H into stack. This H will be pushed into the stack. Then stack will be H. Stack will be have the content, that is H. Pop top element and print and push all neighbor. So print H and its neighbor is H has the neighbor only one, that is A. So when we will push the H, the stack will have the one member, that is H. In the next step, I will pop the top element. So H will be popped. So this H is popped, and on the same step, what is the adjacent element of H that will be pushed? That is A. H adjacent element is A, that is pushed. In step 3, print A, that means after H, A is printed, and pop from the stack, that means A will be popped. H is popped and A is popped, then A adjacent of A will be pushed into the stack. That is neighbor of the A will be pushed into the stack, what I have written here. Similarly, top element will be popped. First B was pushed, then D was pushed. So top element is D. So this top element, that means D is popped. So first element was H, second element was A, third element was D. Then we will consider what is the neighbor of D. It is B and F. So push those B and F into the stack. Similarly, print F and stack will have the only content, that is B, because F has no adjacent, no neighbor content. So B is the only element. So then B is the top element, so B will be popped. Then B has the adjacent element, that is C. So it is the content of the C. Then top element will be again popped, that is C is popped. Then adjacent of C is G. Similarly, in this way, my last element will be that E will be popped, where we will consider that all the elements are popped from the stack and pushed into the stack. Popped will be top element will be popped, top of the stack will be popped, and that top of the stack element, his neighbor will be pushed into the stack. So time complexity is big O V plus E, where V is the vertices and E is the edges. Its algorithm is, in first step, it is you have to ready our stack, push starting node, repeat 4 and 5 step until stack is empty. What is 4 step? Pop the top node, suppose N, from the stack, push the neighbor nodes of N into the stack, then end the loop. end loop. Thank you.